Alright guys, let's talk about some circuits. Now here we have our simple, this is a series circuit, and it gets its name because it's one resistor right after another. So because if you were the current, you'd leave over here, so our current's going to leave like this, and it's going to go around our circuit, and it's going to pass through one circuit or one resistor at a time, and one right after another. Now the interesting thing, guys, is if we look at this, we leave over here from this negative terminal. Right here is where we're going to leave. We'll make it red and we'll call it point A. And we leave point A. And we can only get, we're going to try to go, it's going to try to go to point B. Because remember, electrons are not going to want to be someplace negative. They're going to try to go someplace positive. But they can't go back through the battery. They're going to have to find a new path. And that path is through our series of resistors, one resistor right after another. And the interesting thing is, because there's only one path to get from A to B, there's only going to be one current. And that's extremely important. It only has one current. And again, that's because there's only one path. So if you can find the current here, you can find the current here, and you can find the current here. They're all the same. Series circuits produce the same current everywhere. But let's take a look at the other primary quantity that we're concerned about, and that's the voltage. Now, when our electron escapes our battery on this side, it comes out with 3 volts of potential difference. And we got that from the problem. Sometimes you'll have to calculate that. You'll hopefully use a series of intelligent moves to either find it or use it. So as it goes through, notice from point A to let's have a point X here. To get from A to X, we have to follow this wire. And this wire is a conductor that allows our electrons and our voltage to be transferred. Now, as our electrons go from here, from A to X, there's nothing in between. Now, we'll take an overly simplified view of the circuit and say, well, these wires have no resistance. Therefore, when we get here, we'll have the same voltage that we left A with. So this is going to be basically, we could, if you really wanted to, you could redraw this by just drawing a straight line from there to there, and that could be our wire. We could ignore all this. But we're not going to. I like to draw my nice little big boxes. So what happens though? Each one of these resistors is going to take a bite out of my voltage. So like if I have 3 volts and when I get to right here, I've got 3 volts, and maybe after this I might have 2 volts, and then after this I should have 0 volts. Now you may say, oh, okay, that makes sense, but why 0 volts? Well, when we get back to B, we're going back in the battery. We're going back to the other side. And if we have voltage left over, that means the next time we go through, we'll have even more voltage left over. And it's going to keep building up and building up, and it's not good for our circuit. So everything, we'll be a little idealistic in this regard as well, is that every time our electron travels through the circuit, it's going to get rid of all of its voltage. And if it doesn't do that, it can be dangerous. And hopefully you've seen the simulator. You'll see that it can make some problems. So let's take a look at this, guys. We may want to now say, well, how do we calculate the current? Because that seems to be something important. These voltages, Mr. Shaw, you just made them up. They're not right. You're right, student. They are not right. So let's just get rid of them. These are made up numbers. We can actually calculate the voltages that are taken away. But the first thing we need to do in this situation is find our current. Now, I want you to think of this circuit, guys. If this guy is going to take out voltage, and this guy takes out voltage, and these two voltages that they consume have to equal to what we make, I can say this. I can say 3 volts equals the voltage consumed by 1 plus the voltage consumed by 2. Or I could rewrite this and say 3 volts minus V1 minus V2 equals 0. But I decided I'm going to leave it like this. So now, V1, well, that's the same as, I can use this formula. I can say V equals I R. And that's Ohm's law. And you can say V1 equals I1 R1. And that's the voltage lost to resistor 1 equals the current through resistor 1 equals the value of resistor 1. Or, yeah, multiplied by the value of resistor 1. Okay, so let me actually just write that out because that's pretty important. Voltage lost to resistor 1 equals the current through resistor 1. Sorry, that's poor writing right there. Times the value of resistor 1. So that's pretty cool. That's what this formula is telling us. All right, I'm going to get rid of that, though, so I have space to work. Now, the important thing is also that I can make this formula. V2 equals I2 R2. That's nothing that crazy. It's the same thing as this. So let's combine these guys into a fun formula, and I can say, I'm plugging these in. I'm going to substitute. I'm going 3 volts equals, whatever I have here, I'm going to substitute, equals I1 R1 plus I2 R2. Now, this is a series circuit, though, so you might be saying, well, Mr. Shaw, you told me that all of these currents are the same, and I've got two totally different currents right here. Well, we should put them as being the same. So we should say 3 volts equals I R1 plus I R2. And then like terms we can pull out, we can say 3 volts equals I R1 plus R2. I need to put that in parentheses. And there we go. And this could be an easy way to solve for our current through our circuit simply by having these two values. So you end up getting like 5 plus 9 is 14. And then divide that by both sides and you get 3 volts divided by 14 ohms equals our current. Now, then you'll know, okay, well, let's go back and talk about this. And we can say, well, we said this, guys. We have this before. These are important now. We can say the voltage lost to resistor 1 equals the current, which is 3/14 amps, multiply the value of resistor 1, which is going to be R1 is 5. Oops. So this right here, I used this formula from before, Ohm's law formula, but now I'm talking about the current through resistor 1, which it's this value right here, and then the value of resistor 1, which is 5 ohms. And now you can find the voltage drop of resistor 1. I think it's going to be 15 14ths voltage. And there you go. I found the voltage drop. I said before it was just 1. That was just me being silly. But now we know it's 15 14ths. Okay, cool, guys. Thanks for listening.